Well, hello world. This is Parth Gaglani, software developer at IBM Bluemix Globalization Pipeline Service team, and welcome to the tutorial for Globalization Pipeline Maven plugin. In today's tutorial, we will learn about a Maven plugin that integrates Globalization Pipeline services with Maven build itself, specifically by using Maven goals as GP upload and GP download to perform these bundle operations. This plugin is just a better alternative than performing manual operations because it integrates these operations as a part of a Maven build itself. We will understand its usage, purposes, and advantages by the end of this tutorial. For this tutorial, we will obviously use Globalization Pipeline Service, and I'll cover this briefly in the beginning. Finally, to understand the usage of this Maven plugin, we will go through the default use case as well as the advanced use case. We will use the configuration parameters to control these operations. So let's get started with understanding Globalization Pipeline Service briefly, and then we'll go through the tutorial for the Maven plugin. Alright, let's summarize our services. Globalization Pipeline is IBM Bluemix service, which is DevOps integrated application translation management service that you can use to rapidly translate and release cloud and mobile applications to your global customers. If you haven't tried Globalization Pipeline already, feel free to do so through the catalog tab and creating a new instance for Globalization Pipeline. Finally, if you want to use step-by-step tutorial for accessing Globalization Pipeline instances and other services, feel free to go to the public repository for GP Common. Now let's jump into the Maven plugin tutorial. To better understand the usage of this plugin, we will use an example app which I've already deployed to the IBM Bluemix space at this route. Now all these resource strings are fetched in multiple languages from the Globalization Pipeline instance that is bound to this app in Bluemix. So let's see how that looks like. So in Bluemix, in the dev space, here's that example app that we just saw. Once I open this app, we can see that the Globalization Pipeline service instance is bound to this app. In this service instance, I have created a bundle and I have uploaded all the resource strings and then add all the languages so that our app can fetch all the translated resource strings from here. So for example, we have French translated resource strings here. So if I change the browser settings for languages and put French as the top priority, and then refresh the app, we can see that the French translation have been fetched from the IBM Globalization instance. Note that we simply refreshed and the app fetched all the French translation resource strings which was bound to our app. So if I go ahead and delete French as our language from Globalization Pipeline instance, and then simply refreshing the app again will result into the default English translation resource strings. So we can see how easily without redeploying our app can quickly switch into other languages by fetching all the resource strings from Globalization Pipeline instance that is bound to this app. So while creating this Globalization Pipeline instance, user uploads the translation resource strings in different formats like JSON or Java properties or AMD format. And then user can add languages, edit translation strings, download strings, and can perform other operations. So then this app can easily fetch all the changes from the Globalization Pipeline instance right away. So these manual operations are feasible for now. But imagine a plugin that could upload or download and synchronize translation resource strings automatically as a part of Maven build itself while building or packaging phase, and not doing this process manually. That's exactly what we will do with Globalization Pipeline Maven plugin. So let's finally learn about Globalization Pipeline Maven plugin and see how to automatically upload and download resource strings. So here is the reference URL for the Maven plugin documentation. This is a complete guide which is very well written and is a perfect reference. Please feel free to check out this guide for a complete and in-detailed explanation. So let's go ahead and delete all the bundles in our Globalization Pipeline instance so that when we create bundles and upload translation strings through Maven plugin itself, we can see its results reflecting here. So as we can see, now there are no bundles present in our Globalization Pipeline instance. And now we will perform the Maven plugin operations in the app that we have deployed. The trains app that we saw is also present in my local machine here. and we will perform all the operations inside the pom.xml for that app. We will start with the basic use case of Globalization Pipeline Maven plugin, which is a default behavior for uploading and downloading strings. So let's start with the basic use case. Here we will include the plugin property inside the project, inside build, and inside plugins property tag. And for the basic use case, one more thing we will need is the credentials inside configuration. And the credentials have 4 parameters: URL, user ID, password, and instance ID. And this credential can be accessed from our Globalization Pipeline service under service credential by expanding the view credentials. There are 2 ways to define these credentials, and the easier way is to just include that in our pom.xml. And that is it for the basic use case, as long as configuration is concerned. So here's my pom.xml, and I have just added all the configuration that we discussed. With this particular behavior, that is the default case, the plugin will look for Java properties file inside the src main resources folder, and then any subfolders, and it will upload that string. So in our case, inside the resources folder, I have com, IBM, and trains.properties for my app. That properties file look like this, where each key equal to value, and these are the strings that we saw in our app. Once we upload this English translation, Globalization Pipeline service will add multiple languages and convert these strings into different languages, and our app can access all the translations. So in my app folder, after performing mvn clean install to install the mvn plugin in the local repository, we can simply do mvn gp upload. Now it has created a bundle for us in the Globalization Pipeline instance, and it has uploaded all the strings and added all different languages. So if we see our Globalization Pipeline instance, and we can see that the Maven plugin created com.ibm.trains. And here, as we can see, that we have all different translation available. And as expected, if I refresh my app, I will see the French translation here. Now let's say our app is not in the IBM Bluemix space, and we need the translations to be fetched into the local system. Then we can easily do it by GP download. With this default behavior basic use case, if we perform mvn gp download, we will get our resource strings inside target and classes for the app. Right now this folder is empty, so let's go ahead and do mvn gp download. And it will download all the strings from all different languages. And then as we can see that in our target classes, we have all the strings ready for us here. Also note that GP upload and GP download is a synchronization operation. So if bundle is already present, and if the strings are already present in the Globalization Pipeline service instance, by performing GP upload or GP download, the contents of the Globalization Pipeline bundle will synchronize with the local file itself. So in summary, with the basic use case, the project can upload resource strings in the java.properties file present in the src main resources folder, and it downloads all the resource strings back to target, classes, and subfolder. So that's it for the basic use case. Now to control the configuration like resource strings file location for uploading or target folder location for downloading, or just to choose a different file for the resource string files in different style of folder system, we will use the advanced use case for all this configuration. All these controls can be easily customized with the configuration parameter. So as we can see, here's the default configuration in pom.xml for the basic use case that we just saw. I will add more property tags in the configuration tag as an example case for the advanced user case. So here, after credentials, I have added multiple configuration parameters. So let's understand them one by one. So first big chunk of configuration is the bundle sets, within which there are the bundle set for defining different type of configuration. So let's see the source files. Here the directory defines the location for the source resource string files. Remember, in the basic use case without this bundle sets, the default source directory was src main resources. Now we can configure it to point it to any directory where our source files are. There are also includes and excludes tag, which shows rule to include certain file or exclude certain files. In our case, we have a test directory that I created, inside which I have a test.com directory and I have test.json in there. So this configuration will look to any subdirectory inside src main resources test, and that is test.com in our case, and then any JSON file inside, and it will include this test.json. Another configuration parameter is language ID style. By default, it is BCP47 __, and there are 2 sets of value possible. With the default BCP47 __, it changes all the hyphens to underscore when we do GP download to fetch all the target resource strings. For example, ZH-hant will change to ZH_hant. We can see with our base case that we did before, in our target classes subfolders, we can see how ZH-hant was changed to ZH_hant. Another configuration is language map, which pretty much changes the language ID to another set of strings. So in this case, pt-br will just stay pt. So by default case, as we saw, the target output trains_pt_br will change to trains_pt in this configuration case. Another configuration parameter is type of source file. In our case, obviously we are using JSON file, and here is the test.json that we will use as a source resource strings file. And there are multiple different types of file that we can choose as our source translation resource strings. We are using JSON for now. By default, we used Java, which is Java properties file. Another configuration tab is source language, which defines the source language of the resource strings that we will upload. And output content options to customize the synchronization of the resource strings from local file to the IBM Globalization Pipeline instance source files. By default, it is merged to source so that the local file can replace any translated resource strings in the IBM Globalization Pipeline. There is also a bundle layout to define the folder system of the target folder in GP download. By default, it was language_suffix, which creates different files under the same folder for different target language. We saw that in the basic case, all the target source files were downloaded in the same folder with the different language names. There is also language dir, which creates different folder per language by keeping the same name for the output file. And we will see this case in our advanced example here. There are also other configurations like output dir to define the output directory rather than the target classes directory, and other different options to customize the way the resource string synchronize or uploads or download. As we can see, this was the default case that we used. In our basic use case, this happens on the back end, but we can see that the default directory was the src main resources. It includes all the Java properties files, and type is obviously Java, and it creates zn-hant to zn_hant, for example. It merges the local file to the resource strings in the IBM Globalization Pipeline instance. And also the way output file is formatted is to give different file names to different language resource strings under the same folder. And obviously the default output directory was target/classes. So with our advanced case here, let's see what happens when we upload the JSON file from the src main resource test folder. So that is test.json here. And when our bundle layout is language dir, which will create different directory for different languages, keeping the same name for each target source file. And also it will map the target language to a simplified name. So in our app directory, when we perform mvn gp upload, it will scan for src main resource test folder and any directory inside and any JSON file inside. And it will create a bundle if it's not present, and it was not. And it will upload all the resource strings to the IBM Globalization Pipeline instance, and it will add all the languages. So in our bundles, we will see that a new bundle was created by Maven plugin. And we can see how all our resource strings were uploaded and added to the different languages as well. Now, since we have language_dir as our bundle layout, once I'll perform GP download, there will be different target folders created in the target/classes folder, and we will see the results here. So let's perform mvn gp download, and it will start downloading all the resource strings and create folders. So if we go back to our target/classes, we can see that there are different target language folders created, except the com folder, which was created in our base case. And we can see how there is the same name for each language folder with dedicated language translation in each of them. And hence, by using different configuration, we have customized the way the resource strings are uploaded, downloaded, and saved in the folder system. And that concludes our tutorial for today. Thank you. Exit 0.